collisions, collisions. It's not a hard decision. Give us an A on our project about collisions. When a thing collides into another one, guess what happens? It's a collision. When a thing collides into another one, guess what? It's a collision. Collisions, collisions, it's not a hard decision. Give us an A on our project about collisions, collisions, collisions. It's not a hard decision.
Today, our project is going to be about space-time.
Space-time is the fourth dimension. Space-time also rhymes with tension. Hey! Yeah? Space-time.
No, not that space-time.
Which space-time then, David?
Never mind then. We'll just do stuff with ping pong and bocce. Hi, I'm David.
And I'm Alex.
Do you know that there are physics involved in ping pong?
Really? Explain.
Ping pong is a sport in which 2 or 4 players hit a ball back and forth to each other with bats, which are also sometimes called rackets or paddles. The game takes place on a table divided by a net. Players must allow a ball played towards them only one bounce on their side of the table, and must return it so that it bounces on the opponent's side. Play is fast and demands quick reactions. A skilled player can impart spin to the ball, which makes its bounce and its reaction on the opponent's bat difficult to predict or return with confidence.
And now, for some collisions. Oh yeah.
Bring on the first collision, David.
Let's go.
A 2.7 gram ping pong ball is hit at 7 meters per second. What is the kinetic energy?
The kinetic energy is equal to 1/2 of the mass times velocity squared. We don't know kinetic energy yet. Luckily, we do know mass and velocity.
And then you just have to plug and chug. Ha ha. Na 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 na. Na 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 na. When all the characters full size and every move is level, when all the spirits burning lies, the sinner grief by steel, my eyes burn, claws rush in to fill them. But in the morning after the night I fall in love with light. It is so clear I realize and
To find the impulse, we'll use the equation impulse, symbolized by F delta T, equals mass times the change in velocity. In this problem we are solving for impulse, so we do not yet know it. However, we do know the mass, which is 0.0027 kilograms, and initial and final velocity. Final velocity is 7.1 meters per second, minus the initial velocity of negative 5.3 meters per second. The impulse equals 0.033 kilograms times meters per second.
Bocce set, assemble! first step for bocce is to throw the white ball anywhere you want. I choose there.
The next step is to throw one of these balls as close to the white ball as possible.
Good try, David.
One, two, three, 4.
1.5, 2, 3. That's pretty close.
1, 2, 3. I win.
Congratulations, Jeff. Thanks.
No! Now, if the white ball is not thrown very far, collisions abound.
My turn. I got a bocce. Alright. Two bocce balls, identical mass, collide. The green one starts out stationary. The red has a velocity of 3.2 meters per second. The green one ends at 1 meters per second. So, since bocce balls have the same mass, the masses cancel out, and the equation would be VI plus VI equals VF plus VF. The first one starts out stationary, so it's at 0 meters per second. The second one starts out at 3.2 meters per second. And the green one ends at 1 meters per second. So VF equals 3.2 meters per second minus 1 meters per second, which is 2.2 meters per second.
Awesome. Now, in this problem, we're trying to solve for velocity using the momentum equation. Momentum equals mass times velocity. In this equation, we do know momentum and mass. We are trying to solve for velocity. So we will rearrange the equation accordingly. Velocity equals momentum, which is 3.089 kilograms times meters per second, over mass, which is 1.287 kilograms. Our final answer gives us a velocity of 2.400 meters per second. Cool. Yay.
Hooray.